All right. Hello, everyone. My name is Johan. This is for our final project for Duke COMPSCI 372 project alongside Calvin, who is my partner working on this project. And our project name is called Classical Music Generation Model. So, this is the technical video. So, I'm going to be just briefly going over through the files that we worked on, as well as just a brief review how to set up the environment and run our app. So let's talk about like the files that we worked on. So this is the data split file. So for this notebook, it just mainly helped like prepare the data set, and by loading like the MIDI files, it would identify the composer for like each file name and organize the data for training and validations. And for like the data split, we try to split it based on major composers and rare composers. So with major composers, try to balance them across like the training, the validation, and the test sets. And for the rare composers, we just safely kept them in the training just to avoid unstable validation. And then for our final output, it should generate files for like the training data, the validation data, and for the test data, so that like the rest of the pipeline can use this data directly. And then this is the data pre-processing file that we're working on. And with this, it just converts like raw MIDI files into like formats that our machine learning models can actually use. It produces both like the tokenized text sequences for our transformer models and the piano roll images for diffusion models, and just to ensure that like each format follows consistent rules and sizes. And and then onto like the text pre-processing file here. It just handles like the tokenization and the data set preparation for all our text-based models. So it doesn't help define like a custom tokenizer with padding and boundary tokens, and it splits like long sequences into like a fixed length chunks for more so for efficient training. And it just ensure really that like both our customized tokenizer, our custom transformer and our GPT-2 model can receive like clean and consistent input data. And then here's the util file, and this is mainly like this is just provide like small utility functions that can support like the rest of the code base. And it doesn't just handle tasks like directory creation, file writing, and like automatically select devices if you have like GPU or CPU usage and such. And just keep our machine learning code like clean and just make the pipeline easier to run across like different environments. That's much to say. And then and we heavily worked on this MIDI conversion file. And with this file, it just adds like a translator between like a raw and MIDI data and machine learning representation. So it converts MIDI files into like the structured tokens for our transformer models and piano roll images for our diffusion models using like consistent like timing and quantization rules really, and also support converting like generated outputs back into playable MIDI files. So you're able to play, stop the MIDI files in the app. And yeah, with that, it just allows like the results to be directly evaluated and it can be listened to. And then we worked on this models file, and what this really does is just like it defines like the our um, just defines our machine learning models like used like pretty much throughout the project. So it contains both like our transformer model for like token-based music generation and the unit-based diffusion models for piano roll generations. And it supports features, like casual masking, classifier-free guidance, and conditional inputs, and that's tied to like the music structure and stylistic control into like a for an A system here. And then along with that, we also built like a model helpers file. And with this, it just like defines like it just contains like our shared helper components that support like training and validation across our different models. It standardized like batching, it has like loss calculations and diffusion specific like building blocks, and like like residual layers as seen here, and time embeddings here. And it's supposed to like just keep like the system consistent and just prevents like duplicate like logic across like our different models. And then as for our models themselves, this is our own customized transformer model. So especially with this notebook, it trains like our customized transformer model that can generate music as structured text tokens derived from these MIDI files as the input. The model use like self-attention to just capture like long-range musical patterns, such as like phrasing or repetition and harmonic structure. And what's great about this transformer that we built is that it able to handle like long sequences efficiently, and it just fits naturally to our token-based music pipeline. And then along with that, we also have our um, fine-tuned GPT-2 model. So this is the transformer, the GPT-2 model. So we use the GPT model for like symbolic music generation. So instead of just training just from scratch, we use this GPT-2 model and just fine-tune it on the same MIDI token representation used by our own customized transformer. And with this, what's great about this is also just it just allows like direct comparison between like our own customized model and the pre-trained model using the same data pipeline, which is great for comparison and validation. Okay. And then lastly, here is the diffuse our own diffusion model. With this, like it was the diffusion models that is able to generate music by just denosing piano roll images over time. And as for the architecture, we used the unit architecture designed to just match the image size and normalization choices and made during pre-processing. And with this model, like it focuses more on like the rhythm, noise, and note and density. Um, uh, that yeah, I learned those based from our own transformer models. See here, and these are all the images that are able to generate. And then as for the back end, front end, I'll go this briefly. For the back end, mainly work with the main file. So um, for this, like, it just connects all our trained models into the front end using like the fast API, and it loads our transformer, our diffusion models, and then the fine-tuned GPT-2 models once the at startup and able to expose these API endpoints for different generation models and modes. And yeah, so over here, like we really want to like allow just the user to like generate music unconditionally and even conditionally by composers and keys or by providing text-based prompting for our transformer models. And as you can see with the demo video, I'll point out. And as for our generate outputs, it's supposed to convert back into MIDI files and it's supposed to return as like a base 64 data so that our front end can be able to play or download these MIDI files very easily. See here. And then as for the back end, front end. Sorry, the other one is back end. This is the front end. Uh, we mainly worked in the app and JavaScript. So with this, it just mainly like let the user interact with the music generation system. So we provide like different like separated like interface like for the transformer base and the diffusion based models. And it's much as just allow the users to switch methods and adjust parameters like composers, keys, tempos, and guided strengths. And as for the app itself, I think we used Tone.js and like the MIDI utilities to just play generate music directly in the browser, and with some playback controls, able to play or stop the generating music. And also we include like the AI system prompt drafting to just help the users draft like a generated and valid like musical token input for our transformer models. And with that, I go briefly um, just how to run our models. Run the app here. So go here, let's see here. Mainly most our set will be here. Just follow the instructions below. Mainly make sure to install Node.js and also get LFS. For the get LFS, it's mainly for our GPT-2 model. And then to run like the app itself, you need to install Node.js onto your personal device. As here, just clone the repo to get cloned, and then it should pop up the classical music generation model file. And then ensure that you're on your Python environment. We use Python 3.11. So ensure that um, you install 3.11 and make sure that you run the virtual environment of it, the same Windows. And then make sure to first pip install upgrade pip, and then I'd say afterwards install the requirements text. And here, if you're using a NVIDIA GPU like device I use, a CUDA, basically, you're able to just uninstall our current package, install these packages, and to use CUDA, as well as install this package if you're a Windows user. Again, here it's important to do this step. Just on your locally or even on the environment, just get like LFS install and then pull it, and just so you can be able to use the GPT-2 model. And then I'll show you the back end and front end real quick. And then once you've done that, to use our AI feature, you definitely want to generate a API key, going onto like the OpenAI website and try to get your own API key. And once you do that, just go on the back end, get just create a new file called .env, and then just type here OpenAI key, and then paste the API key that you generated. And as for the back end front end, I'll show you real quickly how to do that. So going back to the website here, it's best if you have split using two different um, sorry, yeah, use two different terminals. So for the backend, it is important that um, get to your Python environment. So go here first, cd to the project itself, then go to your environment here. Yep, following the setup instructions. And then to run backend, just go to the backend file and then copy this from the setup. Also on the README, yep, here, and it should pull up. Should be able to see here, and then application start complete. And then as for front end, it's very important that for the back end, you want to do this on your Python virtual environment, but for your front end, you want to do this locally on the C here with base. Just go to again to the folder for the project, then go to the front end, and then to run, first one do npm install, and then npm run dev as following from the setup. And then see here, it was successfully built the app, and then you just go to this website, just go to localhost 5173. So just copy here, and let me share here actually. See here, and then you just simply paste the link here, and it should take you to our web app. So with that, that's it for our technical video. So thank you all for listening.